Today we're going to take a look at probability. But before we get started on some key concepts, let's take a look back at some key facts that we need to know. First of all, when we're talking about probability, we can use words, decimals, or percentages. So on a number line, we can think of a couple of things. If we think of percentages, we can think of something having a 0% chance of happening, all the way up to a 100% chance of happening. If we think of these in a numerical fashion or in decimal form, we can think of this being equivalent to 0 or 100% being equal to 1.0. If we were to go halfway down our number line, underneath we'd have 50% as our percentage, but as a decimal, we could show that as 0.5. Some of the words that we can associate with probability facts are the following. If we know that something cannot happen, therefore it has a 0% chance of happening, we can say that that is impossible. It will never happen. If we know that something is 100% chance of happening, we can say that that is certain. If we think about 50% or halfway on our number line, words that we can commonly use are things like possible, equally likely, or even. Now, where we can add some additional information are kind of partway through or partway along our number line. So if we go to approximately 75% or 0.75, probability that happen in this range, we can say are likely to happen. If we go lower down our probability line, so let's say around 25% or 0.25, we can think of these as unlikely. So those are some key ways that we can match up words with percentages and also with decimals. When determining and calculating probabilities, or the chances of something happen, we want to make sure that we show these probabilities in 3 different formats. First of all, we always want to set things up as a fraction, and we'll talk a little bit more about that in a moment. Once we have our fraction, we can take that and turn it into a decimal. And after we have our decimal, we can take that and turn that into a percent. So, as an example, if we had something that happened 6 times out of 10, we can put that fraction as 6 over 10. We can then, using our calculator or your math knowledge, turn that into a decimal of 0.6, and we can then turn that into a percentage, so that particular event would happen 60% of the time. Now, the one key important thing that we have to keep track of, and this is a non-negotiable thing, is that when we are working with decimals, and before we take our decimal and turn it into a percentage, we always want to round to 3 decimal places. And that is a key thing that we have to make sure that we do to make sure that we keep everything equaling out. Now, some common items that we're going to use over the course of this unit include coins, dice, and cards. So we'll just talk about those really quickly for some clarification. If I'm using a standard coin, I can flip it and I'm either going to land on heads or tails. We can abbreviate that really simply by H for heads, T for tails. If I'm using a standard dice, a 6-sided dice, we've all used those before, I can roll a number between 1 and 6. Each side has a different number or a different number of dots. Now, with cards, this is where we often have some confusion because depending on the type of deck of cards that you use or the types of games that you play, these are a little bit different in some cases. But what we have to keep our track of is the following information. In a standard deck of cards, and that's what some terminology we're going to refer to, we have 52 cards in total. This does not include jokers or anything else. We take those cards out. We're only using the actual cards in the deck. Next, we have 4 suits. And you've seen these before. So we have hearts, diamonds, clubs, and spades. So our hearts and our diamonds are going to be red in color. Our clubs and our spades are going to be black in color. We have numerical cards, or cards with specific numbers of dots or hearts or diamonds on them. and those range from 2 to 10. And then we have our face cards, which are Jack, Queen, King, and Ace. And we do consider the Ace to be a face card. And we do also generally consider the Ace in most games to be the highest card possible. Obviously, if you play certain games, that may not be the case, but for our purposes, we do need to make sure that we keep track of that. So in each suit, we have 13 cards. So that's, again, 52 cards in total divided by our 4 is going to give us 13 hearts, 13 diamonds, 13 clubs, 13 spades. And if we were to think about how many cards that have black markings on them, we can take the 2 suits that have black markings, divide by 52, so that's going to be 26 cards in total, and then we're going to have 26 cards in total that have red markings on them. When determining probability, we have 2 main types or 2 main categories of probability. We have experimental probability and we have theoretical probability. So with experimental probability, what we have are things where we are actually doing the experiment. And these are things that we can actually calculate. So these are things that do happen. When talking about theoretical probability, what we're doing is thinking in theory without having to do the experiment, because we can have probability situations where there's maybe 1,000 or 10,000 tries, or that would take a long time to do. So this is what should happen. So those are the key kind of differences between. So experimental, we actually do it. Theoretical, in theory, what would happen if we were to do the experiment. So let's take a look at a couple examples. In the experimental example, we have Messi taking 13 shots on goal in the World Cup and scoring 4 times. Ronaldo took 11 shots and scored 3 times. So what we want to know is who has the highest scoring average, or who has the highest scoring probability. Now, when determining this, what we want to take is the number of positive outcomes, and we're going to divide that by the number of opportunities. And what this is going to help us create is our fraction. So when we're talking about Messi, we can see that the number of positive outcomes, or the number of times that he scored, which is going to be our numerator, is 4. And the number of opportunities that he had to score was 13. When we take that and turn it into a decimal, so we can punch this into our calculator, what we're going to get is 0.307, and then a whole bunch of decimal places, but we're going to round right there to that 3 decimal places. So we're going to get 0.308. And if we take that and turn it into a percentage, so again, you can just take on your calculator and multiply by 100, we're going to see that Messi's shooting percentage is going to be 30.8%. If we compare that to Ronaldo's, again, we want to make sure that we set up, most importantly, our fraction in the same way. So the number of positive outcomes, so goals scored, out of the number of opportunities. So how many shots did he take on net? We need to make sure that we set up our fractions the same way so we can compare accurately. So in this particular case, he scored 3 goals out of 11 shots. When we punch that into our calculator and do a little bit of rounding, we're going to end up with 0.273 as our decimal. And when we multiply that by 100, we're going to find that Ronaldo's shooting percentage is 27.3%. So in this particular case, we can see that Messi has a higher shooting percentage. He is more likely to score a goal based on the number of shots that he can take. Now, with theoretical, what we can figure out is, instead of doing a whole bunch of trials or actually seeing what happens, we can see what should happen. So in this particular case, again, we want to think about how we can set up our fraction. And in this particular case, we want to think of the number of positive outcomes divided by the number of possibilities. And it's a slightly different word there, but it is important that we take note of that. So in this particular case, if we're talking about a dice, and a regular die that's labeled 1 to 6 is rolled once, what is the probability of getting a number less than 5? So you have to think to yourself, I have the number 1, 2, 3, and 4. So I have 4 positive outcomes because it has to be less than 5 out of 6 total opportunities, because my dice is labeled from 1 to 6. When I turn that into a decimal and do a little bit of rounding, I'm going to get 0.667. And when I take that and turn it into a percentage, I'm going to end up with 66.7%. So if we were playing a particular game and I rolled between 1 and 4 and I won, and you rolled a 5 or 6 and you won, obviously the odds are going to be in my favor. Therefore, it's not really a fair game, which we'll talk a little bit more in a little bit. Last thing we want to talk about, just before we do some examples, is this thing called range. And when we're talking about range, what we take is basically the largest number that we have, and we subtract it from the smallest number that we have, and whatever the difference is, that is what is going to be our range. So if, for example, on a math quiz, someone in our class got 70% and someone in our class got 100%, we can take the largest number, so that 100%, subtract out the smaller number, which is the 70, so we could say that the range of marks was 30%, or 30 points. All right, as a quick and really straightforward example, we're going to now talk about if we had a whole bunch of cans of soup and we had some different types or different flavors of soup in there, what would the probability of each event occurring? So in this particular case, what we have are 20 cans of soup, and we've taken all the labels off. So from the outside, all they look like are silver cans. They're all the same shape, all the same size. We can't tell what's in them. We know, however, that somewhere mixed in those cans, we have 2 chicken noodle soups, 3 celery, 4 vegetable, 5 mushroom, and 6 tomato. So based on that information, we can go and figure out at random, if we were to pick and make that for lunch or dinner, what would our chances be of getting each type of soup? So if we want to calculate the probability of a can containing celery, all we have to do is look for the number of cans of celery that we have. So that's going to be 3, and divide that by the number of possible cans that we have. So that's going to be 20. Figure out our decimal, which is 0.15, and then figure out our percentage, which is 15%. So if we were to randomly choose one of those cans, and that was going to be our decision, and that's what we're going to have for lunch or dinner, we'd have a 15% chance of choosing celery soup. If we talk about fish soup, and again, we just have to look back through what we have, we can actually see that there are no cans that have fish in it. So 0 divided by 20, which is going to give us 0.0. So there is a 0% chance of having soup with fish in it, which for some people is probably a positive outcome. If we talk about how many cans contain celery or chicken noodle, what we have to think about is how many cans of celery do we have available, how many cans of chicken noodle do we have available. So we have 3 celery plus 2 chicken noodle, which is going to give us a total of 5 possibilities. So we can actually add these together. So in total, to pick either celery or chicken noodle, we have 5 out of 20 cans. As a decimal, that's going to be 0.25, and as a percentage, it's going to be 25%. And our final point, right? If we have a can that contains soup, well, really it doesn't matter what can we pick. We know that all of our cans do contain some type of soup. So we can say that the chances of picking a can that contains soup is going to be 20 possibilities, or 20 options out of 20 possibilities, which is going to give us a decimal of 1 or 1.0, which is going to give us a probability of 100%. Finally, down at the bottom of the page, and again, thinking back to what we talked about earlier, about if we take this and translate it into some words that would correlate to our numbers, state which event in part A is certain. So we have to think which of these options in part A is going to give us a certain answer, or is going to be 100% true, and that of course would be part 4, that we can choose something that contains soup. If we think of something that is impossible, however, so doesn't matter what we do, we're always going to get a 0% chance of that happening, we could say that we're going to pick something that contains fish, because when we calculated up above, we could see that there is a 0% chance of our cans containing fish because we don't have any cans that have fish in them.